Hi, this is the second video for section 10.1, again, where we're comparing two proportions. In this video, we're going to first determine the conditions that we need to do again for inference. They're very similar to what we were doing before. And then we're going to construct and interpret confidence intervals. So again, a confidence interval answers the question, what is the difference? So again, we want to know the difference between P1 and P2. When the data come from two random samples or two groups in a randomized experiment, the statistics P hat 1 minus P hat 2 is our best guess for the value of the difference between the two populations. We can use our familiar formula to calculate a confidence interval. So again, notice the formula doesn't change. We're still going to have a statistic. It's going to be plus or minus a critical value, and it's going to be times a standard deviation. Again, as soon as we meet our normal condition, our critical value is going to be a z, just like we were doing when we were doing one sample proportion intervals. So what are the conditions? The conditions again are the same, but this time you have to do them for each of the populations or each of the samples. So random again comes up, but this time you want them to be two independent random samples from two groups. Again, or if you're doing an experiment, you want to make sure that you've randomized them. We still want to meet the 10% condition. Again, when sampling without replacement, they use the fraction form in our book, but basically if you multiply both sides by 10, you want to know, is the population of group 1 10 times the sample size, and is the population of group 2 10 times the sample size? And then our large counts condition, that's the one that we use to prove normality. Again, we've shown this already in the first video, but we want our n times, and notice it's going to be a p hat this time because we're not going to know p. And then an n times 1 minus p hat, and the same thing for the second group. And you want them all to be at least 10. And then to find our standard deviation, we want to go through and we want to use our standard error that we've done in previous chapters where we're replacing the p's with p hats. So again, when we refer to the standard deviation and we replace it with our hats, that's why they use the words standard error. So it's the same formula as standard deviation, but as soon as you put in your hats, that's when we refer to it as standard error. So what does the interval actually look like? This is what our confidence interval looks like. Again, our statistic is now the difference between the two population, or I should say sample statistics, plus or minus. Again, we're using a z because we figured out it was normal and its proportions. And then here is our standard deviation or standard error of our statistic. And so then we're just going to plug in some numbers and show you how this would work. So I actually want to refer to our worksheet again, quiz 10.1a, and we're not going to do a question on that quiz, but we're going to use the example or the situation on the quiz. So if you could find that quiz, and we're going to walk through a confidence interval from that quiz. So here's our scenario again from our 10.1a quiz, question 1. Again, you have your large bins with 7,000 plastic beads, and bin A is 60% and bin B is 48% red. And we're taking a random sample of 80 from each of the bins, and then we're calculating a statistic. And so we don't have numbers, but I just kind of want to show you of when they ask you the question, what is the difference? Things that you would need to know. If they ask you again, what is the difference? What is the difference? You can't just subtract what you have. Because usually they're going to give you a p hat 1 or a and a p hat 1 or b or 2. So when they ask you what is the difference, you always will be figuring out a confidence interval. So anytime they ask you that question, you will be given statistics, and then you're going to have to go through this entire formula for the problem. So again, they told us that we sampled 80 beads of each. So I'm going to tell you, I'm just going to make up numbers. I'm going to tell you that p hat 1 was, again, out of 80, and you picked out 60 out of 80. And out of bin 2, or bin B, again, you picked 80 beads, and of those 80 beads, let's make them be 47 out of 80. And so then they want to know what's the difference between the two bins. So if they want to know what's the difference between the two bins, the first thing that you have to do is, well, what confidence level do you want? So they'll ask you, what's the difference? What is the difference? And then you'll have to pick a confidence interval, or the problem will tell you, I'm going to do a 95. So if this was sort of our situation about what's the difference between the two bins, again, p hat 1, whatever your 60 divided by 80 is, so 60 divided by 80, so 0.75, minus 47 divided by 80, approximately 59%, plus or minus, and if you're doing a 95% confidence, you have to look that up in the table, and you get 1.96, and then you would plug in your values. So again, p hat, 1 minus p hat over 80, plus p hat 2, 0.59, 1 minus p hat, divided by 80, and you would come up with your confidence interval. So then you would go to your calculator, you could plug all those values in. What did we actually get out of 80? And what is our 95% confidence interval? And approximately, again, you can use your calculator or you can use the tables, but I'm just going to plug it in. My interval will go from 0.01883 up to 0.30617. So I think that the difference between bin A and bin B is somewhere between, there is a 2% difference up to a 31% difference. And I'm 95% confident that the difference between the two bins falls in there. Now, again, they told us the population. We know that our population difference is 12. 12 fits in our interval. So that's how we would use confidence intervals. The last part of this video is to perform significance tests to compare. And that, again, they're going to be asking you, do you have evidence, convincing evidence for a difference? So again, what we're doing is we're just looking for, again, is there a difference? And so your null is P1 minus P2, and typically they start off with this equaling 0. The reason that they have it equal 0, notice what they say, we're restricting ourselves to 0, is we want to first just talk about that there's no difference between your two groups. You could also write that as the two groups equal each other, but it's nice to have a number because we're going to do our calculations and we need numbers. And then your alternative says exactly what we've seen before. Maybe their difference is greater than 0, maybe their difference is less than 0, or maybe you just think they're different. So the hypotheses look very similar to before. We just now have 2 parameters instead of 1. The conditions are the same as what we just talked about in confidence intervals. Make sure it's random for each group, the 10% condition for each group, and then the large counts condition for each group. The test is exactly the same as we've seen it before. You're going to calculate for proportions a z. You're going to have your statistic, which is what was the information from our data collected. Our parameter is again our null, and because if we think there is no difference in our null, that will always be 0, and then the standard deviation of the statistic. That's going to kind of bring up something that we'll talk about this below here, where it talks about a pooled or combined. Because we want to find out the difference between the two parameters, our standard deviation of our statistic will look the same, except that we're going to use a p-hat c. And a p-hat c is where you combined the successes from both groups and the total of each group. And we'll be able to go through an example of that together as a class to show you what does it mean to have a combined sample proportion. So here's what the formula again looks like. Again, we always suppose that the null equals 0. There's no difference. We want to find that combined proportion, successes from both samples, and then we're going to calculate our test statistic. And in case of a proportion, it's a z. We'll use our statistic from our sample data minus 0 divided by that standard error, but this time our standard error has those p combined in it. And then you get your p-value by, once you get your z, looking it up in the table exactly the same way as we had before. If it's greater than, look at the upper tail. If it's less than, look at the lower tail. And if it's not equal to, double it so that you're looking at both tails. So then again, after you run your test, things to just kind of think about. Many important statistical results come from randomized comparative experiments. So again, make sure you always define your parameters, and it gets harder. Most experiments on people are used recruit volunteers. So that means that we will have to randomize how they are used. So again, when subjects are not randomly selected, researchers cannot generalize an experiment to some larger population of interest. We can come up with a result, but you can't talk about the entire population if they were not randomly selected. Researchers can only draw cause and effect conclusions that apply to people like those who took part of the experiment. So again, don't generalize to too many people. It only applies to the people that are pretty much exactly the same as those that took part. And then just things to, again, another thing to be careful of is unless the experimental units are randomly selected, we don't need to check the 10% condition when performing inference about the experiment. Again, because we're not sampling, usually they're volunteers. So this condition doesn't really make sense to talk about, is it part of the sample if we're just having people volunteer. So that's kind of the equation for a significance test and some background on it. We will go through, like I said, an example together on the back side of your 10.1a worksheet, where we go through a significance test and another confidence interval. I hope that gives you just sort of a general idea of what we're covering this chapter in terms of comparing population proportions.